Hi, my name is Omkar Bhatt, and this is my second assignment for visualization. So the data set I've chosen this time is actually video game sales with ratings. Now the data set I received was around 11,000 rows, um, which I had to reduce down. So what I did is I only selected the games, uh, which is specifically for PlayStation 2, and I got my data reduced to around 1,000 rows. The features or the attributes that this dataset provides us are with respect to sales around the globes in different continents, as well as ratings provided for the game by critiques and different users. Firstly, I decided to sample these three datasets, like the dataset into two different parts, which is random sampled and stratified sampled. For random, I directly took random 25% of the data. In the stratified one, I realized it was best to put the data set into four different clusters and take 25% of data from each clusters to make the stratified sample data. How did I come down to the four different clusters? Well, I used clustering techniques on Python to generate a plot to see what was a good elbow selected over there, and the answer was four out there. Okay, now what we're showing here is a scree plot for the PC components of these data sets. The green one is for original, um, blue is for random, and the red one is for stratified. Over here, what we see that random and simplified have high PC components in the first 3 to 4 PC components, while for original, it's kind of spread out, and we see a good number of uniqueness coming out till around fifth or sixth species. What this means is, with the original data set, we are able to find more uniqueness throughout different attributes, but when we sample them, uh, it kind of reduces down to this fewer PCAs. We have a 75% indicator line over here, which shows which of these data sets is actually giving out, like when do they reach 75% of their PCAs. We see that for the original data, it reaches a specie 5, while for somewhere around here, and PC4 is still below 75. And for random and stratified sample data on PC4, we have reached about 75% over here. Um, so we need to figure out if the sample data on a random for the random and stratified sampling is actually giving us any similar data than the original data itself. Let's check out the top two PC components that we received on this. So over here, there is the original, random, and stratified. What we see here is that the original is comparatively very similar to the random stratified data, but very different from the random data. It's because it's possible that the first two PC components in random are actually using a different attribute values than the original and the stratified data. We can figure this out when we see the top three data sets, top three attributes eventually. Coming down to the end, so then we did a multidimensional directionality for all of these data sets to see how they look down using Euclidean and correlation. So in Euclidean, we see that a lot of outliers that are present in the original data set are actually skipped out when we go for random data sets and the stratified data set. But over here, one thing that we can see is the original and the stratified are still a bit more similar than the random, because we tend to see that the limits out here are similar than what random selects. It's seen that random tends to or may actually end up skipping a lot of outliers, giving us somewhat similar data overall. Going to correlation. Now over here, it's much more clearer to us that the stratified data set over here is much similar to the original data set, simply because of the shape that it retains over here. Uh, the random data set is actually very circular, but the original and stratified data are kind of elliptical, similar to each other, which kind of gives an idea that probably they are the ones closer to each other. Next thing we can look at is the top 3 attributes that we received from all of these data sets. We have a second drop down coming out here, which shows us for all the 3 data sets. So for the main data set, the top 3 attributes that we received was the global sales across the globe, North America sales, and other sales. Now, what are other sales? They're basically sales in other continents than North America, Europe, and Japan. Any other continents come under other sales. So we see that these 3 show a pretty good spread around the scatter plot matrix. Now, going to the random sample data, the top 3 attributes here were actually the number of critics who reviewed the data, who reviewed the games, uh, global sales, which is something similar from the main data set, and the year of release. Now, the problem with year of release is since there are not a lot of unique data set values over here, where we don't have a lot of years where a game was released. We see points that are coming kind of far from each other, giving us a good spread, but these are not anywhere close to what the main data set was looking out for. Like in the main data set, the year of release was not really leading to something unique or meaningful in at least the top 3 attributes. Now, moving to stratified sample data set, the top 3 attributes we received here were North America sales, global sales, and Europe sales. Now, this is very, very similar to our previous sales because to our main data set because we see that the North America and the global sales are repeating out here. It's just that the Europe sales have replaced the other sales. So what is happening over here is that the stratified data, which has been removed from the clusters, is actually much more similar to our original data, and it is introducing some kind of biases into our data for sure, but it's surely much better than going for a random data. So next time when we want to reduce our data set down or for any kind of calculations, it would be preferred to go for something like a stratified sampling technique or random sampling technique. Right. So that's the assignment. Thank you.